So we looked at how to simplify radicals when they're just on their own. Now let's look at when you divide radicals. So something that should jump out with number 1 is that we actually have a perfect square divided by another perfect square. So before we do anything, we can simplify those. So square root of 16 is going to be 4, and the square root of 9 is 3. So then we look and see, is there anything left to simplify? 4/3 doesn't simplify any further. So that's our answer, just 4/3. And again, all of these can be checked in the calculator. We could type in square root of 16 divided by square root of 9, and it should equal the same as 4/3. Number 2 is very similar. Again, we have a perfect square on top, square root of 25, that would be 5, and the square root of 16 on the bottom, which would just be 4. Again, nothing to simplify there, it's just 5/4, and we could check on the calculator if we wanted to, just to be sure that we are right. Now, down here towards the bottom is where it gets a little bit tricky. Anytime we have a denominator that has a radical, we need to fix that. We do not like radicals in the basement. Never, ever, ever can we leave a radical in the basement. So what we need to do is called rationalizing the denominator. So anytime you see a radical down here in the denominator, what we're going to do to get rid of that is do the inverse. The opposite of a square root would be to square it. So we're going to multiply that square root of 3 by itself. So I'm going to multiply by square root of 3. Now, if I do that on the bottom, we know with fractions we're trying to change the denominators. Whatever you do to the bottom, you have to do to the top as well. So I'm going to multiply the top by square root of 3. So now I'm going to multiply straight across. 1 times radical 3 is just going to be radical 3. And then on the bottom, square root of 3 times square root of 3, well, if we really wanted to see that, that's equal to radical 9, right? But what is the square root of 9? It's just 3. So really, what we would have is radical 3 over 3. Because again, the square root of 9 right here is just 3. So even though this doesn't look pretty, this radical 3 over 3 is going to be my final answer because there's nothing left to do. I can't divide an irrational number by a rational number. So that's our answer. Okay, same thing over here with example number 4, 3 over radical 2. We can't leave that radical in the basement. So what we're going to do is we're going to rationalize it. We're going to multiply the top and bottom by radical 2. Again, this helps me to undo that square root. We're working backwards. So if I do that on the bottom, if I multiply by radical 2, I have to multiply by radical 2 on the top as well. Okay, and then with fractions, we just multiply straight across. So if I multiply 3 times radical 2, do not put radical 6. Do not put 6 radical 2. That is not what we're doing. We cannot multiply a rational number by an irrational number. So all we're going to do is write 3 radical 2. Okay? Radical 2 is almost like, think of it kind of like a variable. Like if we had 3 times x, we would write 3x. We just write them next to each other. So same thing here. 3 times radical 2 is just 3 radical 2. And then on the bottom, 2 times radical 2, that's just going to be 2. Because again, if I did radical 2 times radical 2, that's radical 4. And the square root of 4 is just 2. So now we look and see, is there anything that we can simplify? Can I divide 3 divided by 2? No, that's not going to simplify any further. So this would be our final answer. 3 radical 2 over 2. Alright, so here's where it starts to look a little bit trickier. It's still the same process. So if you notice for this one, we have that radical that extends all the way down. That's fine. We can write it like that, but we can also write it as 2 separate radicals. So I can write this as radical 3 over radical 2. Okay? Now, these are not perfect squares. I can't just simplify them or get rid of those radicals. So what I need to do, since I have a radical down here in the denominator, I need to rationalize it, which means I'm going to have to multiply by radical 2. So I'll multiply by radical 2 on the top and the bottom. And again, with fractions, we multiply straight across. So radical 3 times radical 2, those are both irrational numbers, right? Those are both 2 radicals, so I can actually multiply those together, and I'll get radical 6. On the bottom, though, radical 2 times radical 2 is just 2. Anytime you multiply a radical by itself, it undoes itself. Okay? So now I have radical 6 over 2. And again, I can't divide these because it's a radical or an irrational number divided by a rational number. So this is my final answer. Just radical 6 over 2. Okay? Example number 6 is very similar. We're going to break apart radical 8 on top divided by radical 3 on the bottom. And again, I want to get rid of that 3 on the bottom, that radical 3. So we're going to multiply it by itself. Again, that's called rationalizing the denominator. So I multiply by radical 3 on the bottom. I multiply by radical 3 on the top. And we're going to go straight across. So radical 8 times radical 3 would give me radical 24. And then on the bottom, we're going to have just 3. Anytime we multiply a radical by itself, we get that number by itself without the radical anymore. Okay, so now I have radical 24 over 3. So we would look and see, is there anything I can simplify here? Well, I can't divide these 2 numbers. However, 24, we should try to simplify that further. We should use our factor ladder for that 24. So now this one's going to require a little bit more work. I'm going to start over here with my factor ladder. Do it right here. I'm going to start with 24, and I'm going to divide that by my prime numbers. So I'm going to start with 2 and see if I can divide it by 2. Let's see. 24 divided by 2 would be 12. 12 divided by 2 is 6. 6 can be divided by 2, and we get 3. And 3 is one of my prime numbers. So the only thing I can divide 3 by is going to be itself, or 1. So I'll divide by 3. And be left with 1, my candle on top of the cake, and then I'm going to list all those factors out. Again, we are just focusing on the top right now. We're just focusing on the numerator of that fraction. So I'm going to list out my 1, 2, 3 2's, my 1, 3, and a 1. And again, I'm looking for groups of 2. Okay, or 2 of a kind. So I have a group of 2's right here. I'm going to pull those outside my radical. So now I have 2 radical 6. And then on the bottom of my fraction, I'm going to have 3. So again, what we did, we broke this apart. We rationalized by multiplying by the square root of 3 on the top and the bottom. Then we got radical 24 over 3, but I knew that 24 didn't look like a prime number. It didn't look like something that wouldn't have any prime factors that would come out. So we used our factor ladder over here, divided by our prime numbers, and then we found that there was a group of 2's in there, so we pulled that out. So really what we did was we rewrote radical 24 as 2 radical 6 divided by 3. So this would be our final answer. If you had a little trouble with that, pause this thing and go back and rework that example with me, okay? All right, let's look at 7 and 8. Ooh, now these are looking tricky. But really, we're still doing the same steps. Same steps over and over again. I'm going to switch to purple now. All right, so I have 5 over 4 radical 3. So first I'm going to look at my whole numbers, my rational numbers, and see if I can simplify those at all. There's nothing here to simplify. 5 can't be divided by 4. I can't reduce that down anymore. But I do see that I have this radical 3 down here. So what I want to do is get rid of that radical 3. I'm going to rationalize the denominator by multiplying by that radical. So notice I don't have to multiply by the 4 out front. It's just the radical we're worried about. So let's go ahead and multiply by radical 3 over radical 3. 5 is a rational number, so we're not going to get 15 here or anything like that. We're just going to write the 5 out front and the radical 3 right next to it. It's 5 times radical 3. Now on the bottom, I have a 4, right? And now I'm multiplying radical 3 times radical 3. Now remember we said that anytime you multiply a radical by itself, it gets rid of the radical. It's the inverse. So really I have 4 times 3 on the bottom. So the last step I want to do is just simplify this. Simplify that denominator. So now I have 5 radical 3 over 4 times 3, which is really 12. Okay, so again, we rationalized the denominator. So we multiplied radical 3 over radical 3. We multiplied straight across, and then we simplified the bottom. 4 times 3 would just be 12. And that's our final answer. Okay, so if you're watching this at home, I want you to pause this and try number 8 on your own. After you try it, then come back and look at the example, look at the work that we do right now. Okay, so for number 8, last problem. Again, we're going to look at what can I simplify right now. Well, first I see I have a 4 divided by 2, right? I can actually simplify that. If I simplify 4 divided by 2, that's going to give me 2. So that means I would have a 2 up top over radical 2. Again, all we did there was just divide 4 divided by 2. That gave me a 2 over 1, or you could just write 2. Okay, so 4 divided by 2 would be equal to 2 over 1, or we can just write 2 over radical 2 here. So now I still have that radical 2 in the denominator. Let's fix that. So let's multiply by radical 2, and we'll also multiply by that on the top, and we'll just multiply straight across. So again, we have 2 times a radical 2, so we're just going to write those right next to each other. And then on the bottom, anytime we multiply a radical by itself, we get rid of that radical, so it's just 2. So now I have 2 radical 2 divided by 2. Wow, that's a lot of 2's. Let's see if we can simplify anything here. So let's look at the rational numbers we have. 2 divided by 2, I can definitely simplify that. 2 divided by 2 would just be equal to 1. And then I still have that radical 2 up top. So my answer, you can write it as 1 radical 2, or you can just write it as radical 2. And that's our final answer. Okay, so we're going to have lots of practice with simplifying radicals, especially when we start talking about special right triangles. So use this as a reference. You can come back to this anytime. If you have questions, let me know. We will be working on this. It does take a little bit of time sometimes to learn how to rationalize the denominator. So again, if you get stuck, if you have questions, let me know. And feel free to rewatch this as many times as you need to.